Welcome to this explainer. Today, we're going to decode exactly how major oil refineries calculate and report their most critical and honestly, sometimes catastrophic safety metrics. If you've ever looked at a sustainability report or an investor briefing and wondered what the safety numbers actually mean, well, you're in the right place. We're going to strip away the confusion and look right at the hard data.
Think about it for a second. We are talking about massive, high-stakes facilities handling incredibly volatile materials. How do they actually quantify severe safety risks without getting completely lost in the technical jargon? I mean, how do regulators and investors know if a facility is truly operating safely or if they're just getting lucky? It all comes down to a very specific, standardized set of formulas. Okay, let's dive into this. Here's our roadmap for today's explainer. 1. Critical incident risk management. 2. Understanding LOPC and PSE. 3. Tier 1, greater consequence. 4. Tier 2, lesser consequence. 5. Calculating the PSE rate. And finally, 6. The importance of total hours. Let's jump right in.
Starting with Section 1, Critical Incident Risk Management.
Before we get to the math, we've got to understand the rule book, right? The guidelines we're looking at today come straight from the SASB standards, specifically for the oil and gas refining and marketing sector. You see, SASB provides this universal language so that companies can transparently report their environmental and social impacts to investors. When a refinery has a critical incident, they don't just get to make up how they report it. They use these exact standards to ensure consistency and strict accountability across the entire industry.
And that accountability is absolutely vital because of the inherent hazards we're dealing with. Just look at what's happening inside these facilities every single day. We're talking about highly flammable and volatile substances, highly reactive chemicals, and processing fluids at extreme temperatures and intense pressures. A strong safety culture isn't just a corporate buzzword here, it's the literal barrier between routine operations and a major catastrophe. Accurately reporting incidents when these systems fail is the very first step in preventing them from ever happening again.
Which brings us to Section 2, Understanding LOPC and PSE.
So how do we actually define these failures? Well, first, we have LOPC, which stands for Loss of Primary Containment. Simply put, this means an unplanned or uncontrolled release of material from a process. But what I really want you to take away here is the second half of that definition, irrespective of whether it reaches the environment. That's crucial. If a dangerous chemical escapes the pipe it's supposed to be in, but it safely gets caught by a secondary backup tray, it's still an LOPC. It escaped its primary containment. The barrier failed, even if a disaster was ultimately averted.
And that leads us directly to our second acronym, PSE, or Process Safety Event. A PSE is the actual measurable event caused by an LOPC. And here's a really fascinating detail from the SASB standards. A PSE includes the release of any material. It doesn't just have to be toxic crude oil or flammable gas. An uncontrolled release of high-pressure steam, hot condensate, or even just standard compressed air, that completely counts as a process safety event. Why? Because a sudden explosion of pressurized steam can be just as deadly to a worker standing nearby as a chemical leak.
Let's move to Section 3, Tier 1, Greater Consequence. Now we need to categorize exactly how bad the event was. What's really interesting here is how clearly the SASB standards draw a line in the sand for a Tier 1 event. An event is immediately classified as Tier 1 if it hits any of these severe consequence thresholds. On a human level, it's a Tier 1 if an employee or contractor suffers an injury requiring days away from work, or tragically, a fatality. For the surrounding community, an officially declared evacuation or shelter in place instantly triggers a Tier 1. And financially, if a fire or explosion results in direct costs of $100,000 or more to the entity, it's undeniably a Tier 1. These are major, significantly impactful incidents.
Next up is Section 4, Tier 2, Lesser Consequence.
But, not every leak makes the evening news. These Tier 2 incidents are serious events that demand strict reporting, but they haven't quite reached the catastrophic thresholds of Tier 1. Notice how drastically the thresholds shift here. For human impact, while Tier 1 requires a severe days away from work injury or worse, Tier 2 is triggered by any recordable injury, meaning medical treatment was required beyond basic first aid, but the worker didn't necessarily lose days of work. Financially, the gap is just massive. While a Tier 1 fire or explosion costs $100,000 or more, a Tier 2 event is triggered at just $2,500 in direct costs. Tier 2 essentially acts as a crucial early warning system. By rigorously tracking these smaller fires and minor injuries, companies can identify systemic flaws long before they turn into full-blown Tier 1 disasters.
All right, Section 5, calculating the PSE rates.
We have the definitions and we have the tiers. Now, let's get into the math. How do we take these incident counts and turn them into a standard metric that investors can actually compare across different companies? It all hinges on this specific kind of massive number, 200,000. Whenever you look at a safety rate in this industry, this number is running under the hood of the calculation. But why? Well, it perfectly represents a standardized block of work. Imagine a group of 100 full-time workers. If they each put in exactly 40 hours a week for 50 weeks a year, boom, that equals exactly 200,000 hours. By using this clever baseline, we can fairly compare the safety rate of a massive global refinery network against a small independent facility. It levels the playing field to a really neat incidents per 100 workers scale. So here is the official SASB standard formula. It's beautifully straightforward. Step 1, count your total process safety events for the year. And keep in mind, you do this entirely separately for your Tier 1 rate and your Tier 2 rate. Step 2, divide that event count by the total number of hours worked at the facility. Step 3, multiply that result by our magic baseline number, 200,000. This gives you your official Tier 1 or Tier 2 PSE rate. But hold on a second, there is actually a massive trap hidden in Step 2. Which brings us to Section 6, the importance of total hours. What exactly counts as total hours worked? Because getting this wrong changes the entire safety profile of a company. The SASB standards are incredibly explicit about this. Total hours worked must strictly include both direct employees and contract employees. Direct employees are the people on the company payroll, but contract employees are third parties, independent contractors, or temp agency workers. Think about a major refinery turnaround. They might bring in hundreds of outside contractors for maintenance. If a company only counted the hours of its direct employees, their total hours denominator would be artificially low, and their accident data would be horribly skewed. If a contractor gets hurt in a Tier 1 explosion, that absolutely has to be factored into the final rate. Integrating both groups ensures the safety metric represents the daily reality of the entire facility, not just some curated list of corporate staff. Which brings us to a really crucial final thought. When you look at corporate sustainability reports or evaluate the risk of a high-stakes facility, you have to ask yourself, is the safety data telling the whole story? Are they transparently breaking down those Tier 1 greater consequence catastrophes versus the Tier 2 lesser consequence warnings? And most importantly, are they accounting for every single hour worked by every single employee and contractor on site? Because process safety isn't just about counting accidents. It's about holding a mirror up to the true scope of risk. Thank you so much for joining me on this explainer. Keep asking the hard questions and keep looking closely at the data.